All right, good morning or good afternoon, everybody. Thank you so much for being here for another AMS Weather Band webinar. Today, we're really excited to have PASCO with us to demonstrate some of their products and their amazing experimentation and data logging tools. This is a little bit of a departure from our weather station instrumentation series, but it looks like it's going to be fantastic. So we're really excited to have PASCO here. So as always, if you could put your questions in the Q&A box, we will be dealing with those, answering them at the end of the session. And I think that's about it. So without further ado, I will hand it over to PASCO to get us started. Thank you again for being here.
Well, thanks, and we're glad to join you here with the American Meteorological Society. My name is Roger Palmer. I'm a product manager here at PASCO Scientific. With me is Heidi Brennan, who's a curriculum specialist, and we're excited to share with you some of the things that we can do with our weather sensor and even thinking about data in general that help students and teachers and the public at large use measured values to understand science better. So with that,
excellent.
Yeah.
All right. Well, I'm going to go ahead and get started by giving you just a general overview of our weather sensor and just let you know how many capabilities that it actually has. I'm going to take you into Spark View. And I have connected the weather sensor here. And as you can see on the screen, there are 4 primary sensors that are in this weather device. And it takes over 20 different measurements. So there's an absolute ton of things that you can do here. One of the great capabilities is our weather dashboard. So I'm going to go ahead and click on that in the quick start experiments. And you can see almost all of the measurements that were represented prior are here on the weather dashboard. When you open Spark View up in English, it's going to automatically open up into customary measurements. If there was something that you wanted to adjust, if you want to go into metric, all you have to do is click and you can change from there. But for this demo, I'm going to stick with customary because that's how we are used to explaining our weather here. So what's great with this piece is that students can actually set this weather sensor outside and they can run and collect data over a long period of time, or they could just do some quick snaps. Another neat feature from this weather dashboard, I'm going to go ahead and start collecting data. So you see the live information that's here in the studio. It is a little bit warm in here because of all the lights. If I want to blow here, I can get a wind measurement. So I'm going to show you how you can look at these individually. All right, so let's go back. I'm going to stop and bring you back. So we have wind chill. This is something for those colder states. You might be aware of that piece. I'm originally from Florida, so wind chill really wasn't a thing for us. Our primary focus was on humidity for sure. And you see you have a standardized temperature reading scale here. We're measuring relative humidity, dew point, and absolute humidity. All of those features are recorded with the sensor right here. We also can collect barometric pressure, and then you can also do location and GPS, which is pretty awesome with this device. On the top of it, we have an ambient light sensor, and that way you can actually measure a luminescence, and you can also look at UV ranges. So the capabilities are pretty great. For wind direction, we have this optional weather vane that you can get with the device. And this way you can set it up. You want to make sure the wind is blowing in through the front here. And then you can get wind direction and wind speed this way as well, another feature. I'm going to click on wind direction. So you can see where there was a live data bar where we were collecting information. You can see where it spiked there. If I want to go back to my weather dashboard, I just click on that dashboard icon. Let's see what humidity is running like right now. You can start collecting data. You can change measurements through the side here. It's very user-friendly, very, very user-friendly. So my primary directive here at PASCO is to develop K-8 curriculum. So I like to show folks how you can do remote data logging using our weather sensor. So I'm going to stop collecting data here. So let's say you want your students, pardon me. So let's say you want your students to create a weather station outside. The device here is water resistant, not waterproof. So students can create nice little weather stations here that protect the device. I just have it hung upside down here with some vents so we can make sure we're getting temperature and humidity data properly. We make sure the students know that those measurements are taken in the shade, important to notice. So here's a general weather sensor. You don't want the kids to have to take their computers outside, so you can actually either have SparkView on your phone and students can enact the weather station from there. But check this out. All right, so from the home screen, I'm going to choose remote logging. And I would like to use my weather sensor. And from here, you see that I'm looking at approximately 8 hours and 3 minutes of memory. So if we're setting up a weather station, it's not necessary that the students are using GPS. So if we disable that, I'm going to go down here. I'm going to disable that sensor. And you see how my memory has expanded to 14 hours here. Another piece that you can adjust to help with battery life and with memory is adjusting sample rates. So you hear we're measuring at 1 hertz, so that's 1 measurement per second. If we're doing a weather station outside, we probably don't need to be collecting data that quickly. And you can see as I adjust the sample interval time, I end up getting much more memory available on my weather station so I can run very long-term experiments outside. Once I click OK, I'm now in remote logging mode. So I can now take this weather sensor anywhere I want, set it up, let it collect data for an extended period of time, and then I can bring it back in. And I don't have to use my same computer to open up and retrieve the data. I know it's going to be really hard for folks to see, but you know that you are connected remotely when your little Bluetooth icon begins to flash an amber color. That lets you know you're good to go. So I can just click OK. And let's see, we're running live, so let's get some wind speed, maybe a little humidity and temperature change. And I'm going to show you how easy it is to come back into the classroom and retrieve the data. I'm going to click on Sensor Data. And I'm going to do a click on my weather sensor to re-engage it. Choose. And there we go. So now you see that I can download the data, and there's a few things you can do. You can delete data after you've downloaded. And this is kind of important because if you don't delete it after viewing it, every time you connect the device, it's going to prompt you to download that data. For now, I'm just going to download the data so you can see. And let's pick 2 measurements that maybe we wanted to monitor. So I'm going to choose wind speed and temperature and my graph. And then you can see how it spiked when I breathed upon this sensor and how the wind speed increased when I blew into the propeller here. So just a really neat feature. You can go back through here and quickly change to other measurements at the click of a button. And that's a remote logging feature. So I've told you about the weather sensor. It has 20 different measurements, including GPS for mapping, which is fantastic. You can do remote logging. Well, let's talk about some activities that we've created here. Most recently, we've created a series of fire weather activities. I'll pull the slides back up. All right, so we have 3 activities, and these are really best served for upper elementary and middle school. We have red flags and fire weather zones, family preparedness plan, evacuation map, and Blockley extension red flag warning. You're probably seeing a pattern here. Here in California, fire danger is something that we deal with on a daily basis, especially this time of year, and we've been having some really out of the ordinary long hot spells getting up to 110 degrees here already. I'm originally from Florida. I went for vacation last month, and I happened to be there when they were in red flag warnings. So it's great for students to be introduced to this and understand what they need to know and how they could prepare. The first lesson, pardon me again, students are challenged with locating their fire weather boundary. Then they do some research and get their annual fire weather plan. This is fantastic because students now can find this information. They know how to go to the National Weather Service, where they can pull this information quickly. Then they go in and they research that fire weather plan to know what are the criteria in their specific area that dictates a red flag warning. And this is the activity where they would set up a weather station outside so they could monitor those particular conditions once they knew what they were for their area. Temperatures possibly over 75 degrees, low humidity, high winds, all of those different factors they really should have an understanding of. Then we take that information, and within SparkView, we have this great new component, which is Blockley coding. So the weather sensor can actually be coded, and you can program inputs that are either numerical or in text. In this particular activity, I did a compound conditional. I knew what my red flag warning conditions were in my area. I plugged that in, and actually there's a live shot of data there, which last month I took outside because we were in a red flag warning, and sure enough, all of those indicators matched, and I got to see right off the bat where we were. And then the next lesson is using the GPS on the weather sensor. Again, remote logging, you can get it set up inside the classroom, and then the students can go outside and walk freely. We challenge them to walk the perimeter of their school and then identify safe areas to meet in case there's a fire emergency, how they need to stay away from certain areas, how they possibly want to, oh, sorry, we've got some noise in the other room. No big deal, I'm gonna keep going. So they map out safe zones. They understand where the fire trucks are coming in, where they can go, where they can be seen, and where they should make sure they're out of the way. And a great component is then the teacher then can send this weather sensor home, and the students can use their devices at home, the free software, and then map their neighborhood and come up with a family preparedness plan for their specific home. So that's your introduction to our weather sensor and some activities to get students started. And Roger now is going to come in and kick it up a notch to show how you can use other capabilities. So he's going to blow me away.
Thanks, Heidi. What's fun as we work as a big team to see what we can do to engage the public using data. Heidi's job is to think about ways we can meet curriculum needs and what teachers are covering. As a product manager, I try to think of what's possible and where we can apply some of our tools and think outside the box of using those together. Let me share my screen. Do I need to share, or can you see that?
You gotta share.
Share it. Got it. Okay. Let me pull that up for you real quick. And I'll start pull this out of the way so I can see my presentation mode here. Oh, let me raise that just a touch. Okay. So one of the things we think about with the weather sensor is how do we engage in the community. I'm going to talk a little bit about the fire lessons that we've written and extend that, saying if you were a team that wanted to see what the fire risk in your area was today, we're going to look at different ways we can do that with the fire sensor. One of the things before I get there is that we can tie what's being measured in the weather sensor with other kinds of probes or data gathering devices. And one of those could just be a movie camera. And here's a good example of a short clip of where we took the weather sensor and tied together just a camera pointing out towards the clouds. And what a great way to marry data and the cloud pattern, okay, over the week for that that weather condition. So not only can I take the weather sensor data, put a movie out, and we do a time lapse over 5 or 6 days, and students can say, well, what kind of conditions create the clouds or the kind of weather that are coming in with the weather sensor? But we also can ask questions like, what information do we need to know that would show whether some place is at potential for a fire risk, such as here in California? And so when we are talking about how do we get the data together with what's being measured, we might talk about humidity of the area because the the fuels as they get to be drier are more available to burn. We can also talk about what's the temperature like out there. We might want to know what kind of fuels there are. All that process, if we go out, we can actually go out into an area just right outside our building, and here's what a field looks like. That we can turn on the sensors Heidi has shown us to go out and measure those variables. Because they're being measured in place with the GPS, I can bring those back and partner not just with the camera like we saw in the previous example. What if I wanted to put this on a map and put other kinds of variables together? So probe data can then be used analytically to come up by adding factors together so that it shows a total risk of all these factors that we say are important. Okay, so first, if I am going to bring this data into a map that I want to see, I'm going to show a process that I can put this into a map itself. This is GIS map. ArcGIS is a common GIS, but you could use others. I could, for instance, take our probe data, but also do a drone shot where I would fly a drone around and I would take their pictures and tie them together. The GIS software can do that. Not only can it put those pictures into a single, I just took 14 pictures of this little field that are out there, but I can use those different angles from each of the picture to build an elevation information model. That's what you're seeing there. The green is the lower areas. The white is the top of the hill that we were looking at in that previous shot. But I can bring that data of how warm the field is on top with this data. And we can use the humidity like I mentioned. So what I have are all the ingredients for a model that I can analytically determine the fire sort of risk parts of the field. If it's around your home, it might be in canyons and the hilltops, or it might be forested sections or grassland sections, for instance. But let's see what I mean by that. First, if I take that elevation information and I find those areas that are steeper, that's more potential when fire starts to quickly climb that fuel higher. And so in this case, the darker values are going to be where it is got larger slope, and the lighter values of those that model are where it's more flat. We can give those points, flat being like 1 in the fire risk potential, but the steeper values being 4. We can rescale that so that they add to the model only, based not on slope, but on some number you've determined. The software, we can make those kinds of choices. Of course, the direction that hill points also is how long is it facing the sun and how long does it have to dry out on previous days. And so the aspect, if it's south facing, we're going to give that as the most potential, like a 4 value. If it's facing north, and in the picture here, the south facing is that greenish, aquish colored look. And then the dark blue is the north facing sort of sections. It's pretty flat and only that one hillside that's facing south. So we don't have a strong blue area, but those we would give different scales of hazard to. Now we'll take our temperature data, which we saw as points when we saw the last slide. We'll give those, if it's the hottest, we're going to give that a fire potential of 4. And if it's the coolest, you'll see it's down towards the left in the yellow area. That's along the creek. It's a lot cooler down there. That has the lowest potential to propagate fire. And finally, I'll take the humidity, and you can see that same strip that's yellow in the previous picture where it's got a lot more humidity, it's not going to be as, and we can see it just by color when you're walking, it's much more lush or green colored, that we can add those all up into a single map. So we take all those little parts that were high risk and some that are low, and we add those all with those values we talk about. We'll come up with an overall map value where the darker red this is, that's what I'm using as those values of all four of those added their 1 through 4 scales. And the hillside facing south, that's warm, that's going to get a 16 of all of those potential factors. Now, you can always change the model to be something more accurate, but this is a great way for learning how to build those models using our weather sensor. So that is a good example of taking our points together with drone information and working together with GIS. Another way is that we can take the sensor out to the field and either hook it to your phone or hook it by itself in its own remote sort of mode to measure. And then when we're done, how that process happens is super interesting, because here is we had it just sitting out in a self-record mode, was in the parking lot just last week. And you can see, obviously, that this is what we're talking about in terms of causing the conditions we have of 117 degrees right next to the parking lot. Now, it probably was 110, which is like, yeah, that's still boiling. I mean, that's still super hot. And so 117, 110, I had a perverse sort of scale every winter because I grew up in North Dakota to say, oh yeah, cold weather is what we brag about. But down here, it's one of those I can take perverse pleasure in being on the other side of saying that is the hottest I've ever been as a local temperature. But we might ask the question, what is driving these 117 degree days? And what's cool is that if I bring some data inside of just an online map viewer, I don't even need software. I just go to arcgis.com and I can go there. And if I've mailed that data set as a file, and I'll just call it something, if I want to say, hey, let's compare our climate data to something else like carbon dioxide output, I can use our carbon dioxide sensor and then compare these to see which maybe drivers, what are drivers to climate that we see. And I'm going to take a look at carbon dioxide. Literally, I can drag that file with my carbon dioxide sensor in the phone because it's got a GPS in it, or I could take these simultaneously together and I could add those to the map literally by dragging it over because they have a latitude and a longitude in them. So then we can examine areas where CO2 is generated. So not only can we take a look at what the climate or the temperature were, I could map, for instance, a heat island effect across the city by taking our weather sensor and driving it around. It has GPS in it. I could then look at the same time what the CO2 is like so that I can start to understand where is that coming from. Those big dots are areas of right next to the highway or in shopping centers on the lower right or the west portion. Southeast portion are near shopping malls or on busy sections. If you go over to the left side of the picture, you'll notice as I leave town, that's a topographic map on the edge of town. As I get out of town, the CO2 drops. It's interesting. Okay. As I turn in the upper left corner, that's the landfill, and there's a lot of CO2 that's there because they have a big composting center. And as you head to the east, as you go to the right on that map, you'll notice the dots get slowly bigger. So there's all sorts of interesting ways students can start to understand not just climate by measuring those climatological factors with our weather sensor, but if we can combine those with other sensors, we can start to understand some of the relationships between those. Of course, as we take a look out online, we can see that there are models that can help then say, what does this have impacting for the world? I'll just turn the one on the left, which is a long-term study of the actual temperatures measured by NASA in a 200-year sort of version. You're going to watch as the temperatures turn more red. That is the actual measured values from either points and extrapolated, or as it gets later in that time scale, that's going to get hotter based on satellite measurements. On the right, we can see what's happening is we're showing a time scale of fires in California, and we're up to 19. This is going to be the last 100 years of fires in California. But you're going to notice as they make the largest fire scale, we're still right now in 1955, and we've only had one major size fire. So the first 50 years, we had one largest fire in the top 10 fires. And as we watch that scale on the left, we saw in the last 20 years, the hottest years ever showed up in those. But as that heat rose, we're going to have a long-term impact. We're now in 1980, and we've had 2 more. So by 80 years, we've only had 3 of the top 10 fires. What's going to happen is you're going to see in the last little bit of this sort of scrolling map that's in the bottom right, we're going to start to have, we're currently in we're in 2013, and we're starting now fill in these others. So in the last 10 years, we had the rest of those 7 top levels fires. And it's interesting to see that is that necessarily a coincidence? And I think is the discussion that we're having in terms of long-term climate. I think those would be great discussions to have with our students. So with that in mind, thank you very much. And I think we're ready. I'll ask Heidi to come back in, and I'll put my headphones on so that if you want to turn on your microphones, or if you want to type in your chat boxes there, I'll go ahead and plug in as well so we can have a conversation about how we use our sensors for questions.
And I think it might be helpful for our folks to see where they can access our lessons.
Perfect. I'll stop sharing so I can see the chat. All right, if you have any questions or you have any comments while Heidi finds a good place for some of our lessons, I will take a look at that.
Okay, so I have brought you to PASCO.com. Can you still hear me okay?
Yeah, just your screen is unshared.
Oh, thought I hit that. Sorry about that, folks.
Well, that's coming up. Hopefully you've seen the potential as an instrument that can measure temps, humidities, those kinds of things, can have part in the discussion about climate.
There we go. Screen share. Share screen. Okay, I'm at PASCO.com, and I'm going to click on the Resources tab. And from here, I'm going to go to Experiment and Library. In the product title, I'm going to put in weather sensor with GPS, filter, and then you can see the newest additions here are those lessons we shared with you previously, the ones specifically for fire weather related incidents, but we have many more activities that are already set in the experiment library, where the student documents are actually in Word and PDF. So if a teacher wants to either decrease complexity or increase complexity, they have that option. And then we also have an extensive video library where you could also search for videos that we have with the weather sensor. All right, so we ready for some questions?
Mm-hmm. Well, those may be coming in. One of the things I wanted to say is that I had taught for 28 years, and so the lesson of the fire risk, it was something that we built over a couple of days with students, and they had a class that was sort of a capstone class, so that worked out well for me to think of ways to use probes and to use GIS together. So it wasn't necessarily just saying, oh, this is a cool way to show off what we do. It was a great skill for kids to ask their own questions.
I actually had a question about that, if you don't mind. You showed a lot of...
Go ahead.
Thanks. So you showed a lot of data assimilation with ArcMap and in ArcGIS. So do you have a partnership with Esri? Is that something that people can access if they do have your sensors, or is that like a separate
Correct. Our partnership involves the schools. Actually, Esri is offering their software for free, their online software for free. And you can also work with them about the desktop software, which was some of my examples. So if you look, I think it's esri.com/schools, try that, or Google those. You'll see you can ask for a license. And then if you use our data that you've measured with field sensor, that you can, as long as it's a text file that you've exported it from our software, you can drag it right into the online map. And if you want to do more of those analytical things like interpolate the data across a field, for instance, I would use the desktop software.
Fantastic. Thanks for explaining that. That's very helpful. We did have one question in the Q&A, but I'm not sure it was a complete question. Sorry. So I don't want to ignore it, but it was just, does the weather sensor have a complete blank? So I'm not sure what that question was. So if you did type that question and have some additions that you wanted to add in there, please let us know what that would be.
Oh, okay, I see.
And then in terms of the
instruction manual. Yeah, we can show them how to get to that. I'm going to go to products. You can again just start typing in weather sensor.
Your screen is not shared.
Thank you, sir. There we go. All right, so I typed in the wireless weather sensor GPS. I'm going to click on that products. From this page, you can see the descriptions of all the measurements that are taken, specifications of the products. So if you're looking for specific ranges for each particular measurement, then you also have over here on the right the documents guide, and there you will find our reference that explains all of the features with the device and how you can access them.
Looks like there's 2 questions in the Q&A. Can you see the Q&A?
For how long is it possible to detect the weather data? Oh, it disappeared.
Yeah, it's an answer.
Oh, okay.
Okay.
Oh, JP typed it in. Okay.
Perfect.
So we have somebody following the chats as well. It says, we're planning a field trip to a solar eclipse. It seems that you could use the sensor to document changes in illumination and temperature during the event. So yes, indeed, if you'd start your sensor and you could position it straight towards the sun and then follow the two, because they'll be measured at the same time.
And I believe, didn't we do something like that when we had the total eclipse here? It was just before you and I started working here. I believe they might have done something like that
With the light sensor.
with the light sensor.
But it's really cool data.
Yeah.
You were asking if we had any learning module there. You know, once we start to ask great questions, we just encourage people to take it out, especially if you're running your phone, because you can be outside and doing this together, and just start measuring. And you'll get a graph if you choose the axis to say, show me the illumination, and it should show me the temperature, and you can follow those two together. I don't want to diminish that we have many, many lessons, but as soon as you say, oh, I've got 100, you'll be like, oh, I'd love to do this one. And, and that's the fun of science, is to think about how you can get some measurements to answer or address a question. If your students walk away just saying, I just want data to answer a question, for me, in the years I taught, I would have been, I succeeded. That would be great. Some of you may ask if, how many how many pieces of equipment do I need to do this? If you're good and thinking about, I want to just show this on my projector when I get back to class, one would be sufficient to get them started. And then if you want your students to be able to start asking questions and doing that, I always love getting many sensors into the hands of kids. And your budget allows to get a set for your class. You can use it in yours when you're doing something. You can hand it over to biology, and they could be following, the growing conditions for plants in the garden. You could be giving it to earth science, and they want to be able to measure, like I did, the temperature on a day and see what it's like for CO2 or clouds or any questions you really ask. So having 1 or 12 for a class, for instance, so every other student can have their hands on it is a great way to get them doing science. Well, you can see the question is, how weatherproof is your sensor?
Yeah.
In this direction, there's a rubber seal around the outside. If you get water onto the circuit itself, there's a small bit of a circuit in this window. That can cause some corrosion over time if it gets wet. And while it is got weatherproof, it isn't waterproof. So I'd say, if you're putting it out and you've got a roof over it for, like a big rain, that's pretty good and it should last there. But if you say, I'm going to stick this in the water and see how fast the water's flowing, I'm going to guess you're going to find out it'll fail. If there's a large fire, can separate groups send in handheld data to a central fire manager for analysis? There's obviously some issues of safety when you're dealing with live fire. But really, if you're out in that kind of rugged environment, I'd say you probably want to grab data that you can analyze afterwards in the remote sensing method. If you have a phone and you're measuring the two, you can be measuring them and share that data. You'd start a shared session, but again, that's all fairly technical. In the middle of a fire, I would say it's not an ideal situation where you can see those. I'm not saying it's impossible. I'm just saying it takes some thinking about how to make that automated in a way that's not putting you in the way of the fire.
We did get a question regarding to downloading our software. Let me just move this out of the way. I'm going to bring you back to our website, and I brought up pasco.com, and then if you click on downloads, the question was specifically for Windows 10. You can get, I'm going to go to SparkView here within downloads. You can get test versions, sorry about that. You can download free trials for Windows 10 and for your Mac computers, but it's also a completely free download for Android phones, for your iPads,
mobile platforms,
and Chromebooks, which is really critical in terms for students right now that are mostly using Chromebooks in their classrooms. So yes, you can download it for free today.
And in reference to Bob's previous question about can you do this live and send the data, we call that a sharing or a data, what's it called? Data.
I'm sorry, can you say that again?
To send data and share it between a remote site and somebody else, it's the shared session. It's called a shared session.
Yes.
But I wouldn't say it's made for automated, like the intent of your question, I think, is we don't do that. It's a great question, and I think it'd be a cool challenge to make it work, but we weren't designed for that sort of use. And that being said, I'm intrigued to put on some remote vehicle and have it drive through someplace and get data or something, but that's a good thought.
Okay, I'm not seeing any other questions.
Yeah, I think that will wrap us up for today. And then if people have any other questions, we can send them from the AMS Weather Band community. So we'll share the recording of this with our Weather Band members, and we may generate some more questions there, because this is a lot of information to take in and a lot of exciting, especially those lessons to think about, and to think about different implementations for these sensors and these tools. So thank you so much for walking us through all of this. And again, please join us over on amsweatherband.org in the community if you do have any further questions or want more information on any of these products. And I think there's been a lot of links shared in the chat as well. So if you have any direct product links that you're looking for, look in the chat. So thank you so much for sharing this information. We're so thrilled that you were able to join us today. And again, I'll just say thank you and have a great rest of your day.
Thank you. Appreciate the opportunity.
And if there's driving questions and you watch the video, you saw our contact information in the first slide. So feel free to contact us as well.
Fantastic. Thank you for that. And bye, everybody. Thank you so much for being here today.